Welcome to today's webinar, specially focused on using Aerohive's CloudShark integration to troubleshoot your cloud-managed Wi-Fi in Hivemanager NG. With me is Tom Peterson from our CloudShark support and development team, and he's going to be showing you how to solve a real problem putting all these things together. So one of the things that we've often encountered here at CloudShark is that not everyone involved in IT or in managing networks is familiar with the why of packet captures. So this quote here is from the lead developer of Wireshark, which is the software that most people learn when they start learning about the usefulness of packets. And what he says here is very telling. Packets really are the best way to get to a root of a problem. So why are they used as a last resort? Well, the answer is that they are difficult to collect, share, and work with. This pain is acutely felt in the explosion of cloud-managed Wi-Fi and cloud-managed networks, which are quickly becoming the norm. These systems allow their access points to connect to a cloud-based management system, making it easy to manage, monitor, and configure them from anywhere, usually right in a browser. But how can we easily debug network problems that arise on these systems when they are remotely distributed? You want to take captures and get access to them, but it's often hard to do without special software. And trying to use something like a Wi-Fi probe very rarely gets you all of the data you need. Moreover, you can't get the unencrypted data very easily. And it's also equally difficult to try to grab captures from mobile sources in this situation. Well, lucky for all of us, the folks at Aerohive kind of get it and understand this problem. They've added native packet capture and CloudShark integration to their platform via their Hivemanager NG dashboard, where users can be monitoring their APs, see a problem, run a capture, and send it to CloudShark, where the analysis happens all without leaving your browser. They've done this because they understand how important it is to be able to do this sort of thing, and that PCAPs should be one of the first things you use, not the last resort when getting to the root of a problem. So we're going to show you how all of this works. First, Tom will take a look at how to link your Hivemanager NG dashboard with CloudShark using your CloudShark API key. Next, he'll show you how to take your first capture, which is instantly sent to CloudShark. And then after that, he'll show you the immediate things you can do with a capture, how to share it with colleagues or customers, and an overview of the basic web tools that CloudShark offers. And then lastly, Tom is going to go through a real example of an application problem we were able to solve here at CloudShark using Aerohive and CloudShark. All right, so I will turn things over to Tom, and he will get into Hivemanager.
Thanks, Jason. I'm Tom from CloudShark. So I'm going to start off by showing you how to set up your Aerohive dashboard with CloudShark. So we'll start by logging into our account. All right, so once you've logged in and you can see the dashboard here, you can go right up into Tools, and we're on the Remote Packet Capture button right now. So it's very quick to get to. Aerohive's done a great job setting it up. So you just click this first link. That's going to bring you to CloudShark's site where you can sign up for a free trial and set up your account. Once you've finished setting up your account and you have your password, you can log into CloudShark. And then by going to Preferences in the upper right and API tokens, you'll have one already created for you as well. So you can just copy this token right here, paste it right into the box Aerohive has set up for us. And once you've clicked Add, now anytime you go to Remote Packet Capture, you'll see a list of all the locations that you have. You can click on a particular location and view all the access points in that location. Once you've selected one, you can specify a duration. We'll do a short one here just to test it out and show you an example. So we'll do 10 seconds. Once we hit start, this is going to start a capture on the Aerohive AP that you selected. You can specify a duration up to 300 seconds here. And you can also specify a limit for the number of packets that Aerohive is going to capture. And once the capture is done, it's going to pop right up below this, and you'll get a link directly to the capture that you can click on and open up right in CloudShark. So the first thing we'll do is we'll go into our profile here. We have a few presets for these columns that you see up top. And since we're looking at wireless traffic, we're going to make sure our wireless preset is selected. Click Save, and now we can see some information like the PHY type each packet is being sent on, what channel, the signal strength, and the SSID. You can also see who's the sender and receiver of all the packets. If you scroll through here in our example here, you can see we're seeing a lot of different SSIDs. We have a test network here with a lot of wireless traffic going on. So one tool that we have here to get a quick look at all the wireless networks that you've captured. The Aerohive is going to capture all these beacon frames. So that's what's going to populate this table here. And we can see a list of all the base station SSIDs, the SSID itself, the vendor, signal strength again, what channel it's running on, and you can also look at the security to see what security is in use on this network. So we've got our Aerohive network here, and we're going to click on this one. We can see it's using WPA2 with a pre-shared key. And as soon as we click on that, we can view all the packets being sent on this SSID. One of the first things to notice here is we're actually seeing traffic at the IP layer. So we're seeing decrypted packets. When the Aerohive performs a network capture, one of the things it does before it saves any of the packets that it captures is it decrypts the packets for us. So once we've done a capture, we can go through and we can actually see what's being sent. We don't have to worry about trying to input keys or decrypting this traffic. Aerohive's done a great job at making that real easy so that we can actually just look at the packets that we need to. So since we are looking at these decrypted packets here, we can actually use some of the other analysis tools that we have in CloudShark. One of them to get kind of a quick look at what's going on in a capture file is you can look at a protocol hierarchy. So we can look and see that we're seeing all WLAN frames, but we're also seeing IP frames. We can see there's some IPv6 on this network. And then clicking on any of these is going to get you back to the packets being sent with that protocol. It's going to pre-populate this display filter here so that you can filter out to look at just the frames on that protocol. You might also notice that has also become a part of our URL up here that we can then share and link to so that someone else opening this capture with that link will get this filter. And they'll be looking at exactly the packets we are. Another interesting analysis tool that you might look at when you're first starting out doing one of these is the network endpoints. So here we can see a list of just all the endpoints sending or receiving traffic on this SSID. We can sort these columns to kind of look at who's sending the most packets. We can look for top talkers. We can do that with bytes as well, and depending on if they're being transmitted or received. We've got GeoIP information on some of these IP addresses too. So if you see a public IP as opposed to a private one, we'll perform a lookup and show you what city, what autonomous system is sending that traffic and what country it is. We've also got a GeoIP map that you can click on. That's going to show us a visual display, show us all the countries, and it's going to highlight countries based on either the number of endpoints, the total packets. We can look at something like that instead. You can also do that with this chart down at the bottom, this table, so you can sort based on these. And then once again, like most things in CloudShark, if you click on something, so in this case, we'll look at the packets that are being sent to the United Kingdom. If we click on that, that's going to generate, again, a display filter that we don't have to type in or remember how to generate. And this one in particular is going to show us all packets that are destined to the United Kingdom. So here we can see we've got someone, looks like someone pinging the UK for some reason. Who knows why? If that was going to a different country, we might have to track that down. So that's kind of a basic way to just show a packet capture. A couple quick tools that we've used. We do have a whole range of analysis tools here. So if you're debugging something like VoIP calls being transmitted on your wireless network, or if you're looking at HTTP traffic, you can use these tools as well to help you, since the Aerohive has decrypted all those packets for us and we can actually see them, so we can analyze this traffic. So what we're going to do next, let me clean this up a little bit here, is we're going to go through a real example. This is a real world problem. This is something that we had something very similar happen here at CloudShark that we use packet captures to solve very easily and quickly. So we're going to show you how you could solve a problem like this now that you can very easily take a packet capture and start with those as your first means of troubleshooting, as opposed to one of the last. So we'll go back to our dashboard here. The description of the problem is we've got a ticket in from a user that says they can no longer log into our intranet site. So we have some webmail and everything set up on an intranet site. This user was able to log in yesterday, and now they're complaining that they can't log in from their laptop, wherever they are. So the first thing we're going to do is we're going to contact this user, and we're going to have them get ready to try to log in while we start a packet capture. So I'm going to set one up here. Got to get a list of our access points here. Just try and reload this page. There we go. So we've got our access point. We're going to set this capture up. We're going to make sure we're going to crank this up a little bit here. So we're going to capture 10,000 packets, and we're going to give the user, we're on the phone with them. So we're going to give them 30 seconds. We're going to start this packet capture. Now that it's running, we're going to have them try to log in to our intranet site. And then once this is done, we'll be able to dive into the packets and tell the user we'll be investigating it.
So while this is going on, so Tom, what would you have to be doing right now if you didn't have this capture capability to solve this problem?
Well, we still have to go talk to the user, but instead of just being able to do this packet capture while I'm sitting at my desk, I'd probably have to go find them, install software on their laptop so that we can actually perform a packet capture if we're even allowed to. If they're using something like an iPad or an iPhone, that's going to be really difficult to do. If we can't actually go find them, maybe they're working remote, we have to walk them through downloading software to perform a packet capture. Have them do it and email us the resulted file. And at that point, that sounds like a lot of work, so I'm probably going to procrastinate on that a bit. I might try and talk to an application team member to see if they can look at some logs for me. But that's a lot of work, so I might not start there. But now that we actually have a packet capture, instead, we can click on this, and we've got all the packets that were being sent while the user was trying to log in to our intranet site. So what we're going to do is we're going to start with our analysis tools. I've already looked up the IP address for our intranet site. It's this one right here, 172.16.0.65. So we can click on this. It's going to get us a packet capture, a filter expression showing just the traffic to this host. We know that the user is trying to log in over HTTP, so we're going to add that to our filter expression. And now we've got just 4 packets to go through. We can look at what's being sent here. I'm going to start with a follow stream. So this is actually going to show all the TCP data being sent back and forth between the client and our intranet site. So in this follow stream, we can see them requesting our intranet.lan site. We can actually see the intranet site sending back the HTML with our login form. So we can see all that. Then the next thing we see here is we're seeing the user posting to the login form. We can actually see their username and password here as well, which is kind of worrisome. Don't really want to be able to see that just by doing a network capture. So we're going to make a note of that, but for now we'll just see why they can't log in. So the next thing we see here is an HTTP redirect saying that you should be posting this to HTTPS at intranet.lan/login, which sounds like a good idea because that way we wouldn't be seeing this user's login and password. We'll probably also have to tell them to change that now that we've seen it. So we'll just make a quick note using our annotations tool here, just so we don't forget that we are seeing the user's password here. That'll just let us know, that'll let us jump right to this packet. We can actually see this if we look at all the comments and annotations in here. So this kind of gives us a nice way to just make a note, something to look back at later. So this redirect was redirecting the user to HTTPS. HTTPS is done over SSL. So in addition to looking at HTTP traffic, we actually need to look at SSL traffic as well to see what the client did after being redirected there. So we'll apply this filter, and we're actually not seeing any SSL traffic. So that's awfully strange. Instead of looking at actual SSL traffic, we know that HTTPS runs on TCP port 443. So we're going to change our filter expression to dig down into the TCP level to see if maybe we're having an issue there. And once we hit apply on that, what we can see is after receiving this redirect, we actually do see the client trying to contact our intranet server over port 443, just like the server told it to. But what we're not seeing is we're not actually seeing any response from the server. So that sounds like either the server is not actually listening on the port it redirected the user to, or there could be something in the middle stopping these packets from getting to the server or the return packets going through. The first thing I'm going to do is I'm actually going to try to log into the intranet site as well to see if this is a problem with the whole application. And it looks like I actually can log in to the intranet site here. So that makes me think that the server is actually listening on this HTTPS port. But there's some reason why this user's TCP SYNs aren't being responded to, but mine are. I'm actually on a wired network in the office. So what I'm going to go do is go look at the AP that we took this capture from, and we'll look at the configuration there to see if there's something else that could be stopping this traffic from going through. So we'll look at our network policy here for this AP. We've got our wireless settings and the SSID that the user is connected to. We're going to go look at the user access settings so we can look at the firewall policy. And what we can see here is we've got a policy here that looks like it's going to, by default, permit any traffic going anywhere. It's actually denying traffic to this network that our intranet site is running on. But right above that, it's actually allowing HTTP traffic in particular to intranet.lan. So it looks like logins maybe used to be working over HTTP, and possibly due to the fact that that password was being sent in the clear, one of the other teams might have changed that to redirect the user over HTTPS. So what we're going to do here is we're going to just add another rule to our firewall. We're going to specify HTTPS, and we're going to specify that with the destination of our intranet site so that our user can log in while they're connected to this SSID, and move this up so that it's above the rule that would block all traffic there. And we're going to see if this helps fix the problem and let the user log into our intranet site. So we'll save this user profile. we'll go and we'll deploy this policy to the AP that the user is connecting with. Once this policy has been deployed successfully, I can go back, and first thing I'm going to do is I'm going to queue up another capture so that now I can call the user and ask them to try to log in again, see if the problem is resolved. So I'm going to start this capture here. We started this. Now I'm going to call up the user and ask them to try to log into our intranet site again. We'll have a packet capture ready just in case that didn't solve the issue. But I was able to do all this by sitting at my desk and using the phone rather than trying to hunt this user down who knows where they are. If that's a different site, I'd even have to go drive over there. So I probably wouldn't be very interested in trying to use a packet capture to troubleshoot this issue.
Which is unfortunate because it did make it significantly faster when you're able to actually use it.
I was able to look at exactly what the client was sending and compare it to what I'm seeing myself. And the packets brought us right to the problem. So the user said they can log in again. Let's take a look at what is different now that we've updated that firewall rule. So again, we're going to go to network endpoints. We're going to select our intranet server here. So we know again, we are looking at HTTP, and maybe this time we can actually see the SSL traffic. So we'll use that as our filter expression. And now we can see this same post that we saw before. We can see the redirect. We can actually follow this stream and look at it again. We can still see the user's password. They did change it to super secret now because I saw the first one, but now I've seen this one as well. So that's definitely not configured correctly. But now I can actually see this SSL traffic. I'm going to switch over to, we have another profile set up for HTTP since that's the protocol we're looking at here. And that's going to change our view a little bit so that we can see, still the source and the destination, but we can actually see what site the user's connecting to. So we can see them connecting to the intranet. This data is now encrypted. So they're probably sending their password again, but this time we won't be able to look at any of that. That's all encrypted application data, which is really what it should all be. So it sounds like, maybe the application team got a bug saying that logins were being performed over HTTP. They tried to fix it by configuring the server to redirect the user to HTTPS, but the problem is that only happens after the user's already posted their super secret password to our intranet site. So now what we're going to do is we're going to make a note of this. And
so Tom, in those annotations, that's marked down, right? So if you wanted to put a link in there to the follow stream.
Yep, I could add a link directly to that. So let me show you what that looks like. We're going to go follow stream again. This time we're going to open this up in a new window. And we can actually get a link to the stream itself here. So we can send a link directly to that stream. We're also just going to add a link to in our annotation. So we can say, look at the follow stream. And that's going to show them exactly what we're seeing when they click on this. That's going to open up in a new window. It's going to be pretty hard to miss that. And now we can send this back to our application team with a clear description of what's actually going on. The packets don't lie. This is what's actually being sent over the network. So we can copy a link right here. This has our filter expression embedded up in the URL. So we can send them a quick email. We can share this with them so that they'll be able to see it. And, for example, if I open this up in the incognito browser where I'm not logged in, if I were to send them that link, they're going to be brought exactly where I want them to be, so that they can look at the follow stream and see that, yes, this this configuration didn't help. It sounds like it would. It seems like redirecting the user to HTTPS would be a good thing, but the problem is when you look at these packets and see what's going on, it's not helping enough. So now we've got a clear description of the problem, the proof is in the packets, and now they can go and update their site to do this a little more securely.
Awesome. Well, thanks, Tom.
No problem.
So just a quick overview of what we were just seeing. Bottom line, like Tom said, the packets don't lie. It makes things a lot easier to do things. But packets, it's hard to work with packets normally. And that's no big secret. But with the right tools, that can be a fast and powerful troubleshooting resource. Luckily for us, Hivemanager NG has this CloudShark integration that makes it easier to get packets, even if the system is remote. And once you have that data in CloudShark, it makes it much more easy to collaborate on and solve problems. All right. Well, thank you everyone for joining us. And we, like I said, we'll be making a recording of this and posting it in various locations. We'll give it out to people who specifically want it. But other than that, we hope to see you again and enjoy the rest of your day.